Alrighty, section 3 of chapter 8, multiplying polynomials. So before we multiplied polynomials by a monomial, so many terms by one term. Now we're going to talk about how to multiply binomials using the FOIL method. Remember, bi means two, like a bicycle has two wheels. So when we multiply binomials, we're multiplying two terms by two terms. We're going to talk about what the FOIL method means. And then we're going to talk about multiplying polynomials using the distributive property as well. So the new vocab is a FOIL method and what's called a quadratic expression. So to multiply two binomials such as h minus 32 and 1/2 h plus 11, the distributive property is used. Binomials can be multiplied horizontally or vertically. And again, I prefer the horizontal method. I think the vertical method isn't as user-friendly. But we'll go over both, and you're free to use whichever one you want. So if I want to find the product or multiply 2x plus 3 times x plus 5, you have to first multiply by the 5. So multiply the 2x plus 3 times the 5. So 5 times 3 is 15. 5 times 2x gives you 2x. So, or it's similar to distributing the 5 to the 2x and the 3. Then you multiply the x times the 2x plus 3. So x times 3 is 3x. Notice I put it down here under the column for the x's. And then 2x, or x times 2x is 2x squared. Notice I made a new column for x squared terms. So that's the same as distributing the x from the x plus 5 to the other set of parentheses here. You get 2x squared plus 3. Then you just add the results together, combine like terms. So 2x squared plus 13x plus 15. Okay? Now the horizontal method is you take the 2x and multiply it to the x plus 5 like this, and the 3 and multiply it to the x plus 5 like that. And then you just kind of distribute it and distribute the 3. And then you would get 2x squared plus 10x plus 3x plus 15. Then you have your like terms right here. And you get 2x squared plus 13x plus 15. You should get the same answer because it's the same problem. We just did two different ways to get that answer. Alrighty? Now let's do this one. Okay, we're going to start off with the vertical method. So x minus 2 times 3x plus 4. Set it up vertically. Multiply by the 4. So 4 times negative 2 is negative 8. 4 times 8 is 4x. That's like distributing the 4 to the x minus 2. Then you multiply by the 3x. 3x times minus 2 will be negative 6x. Remember the signs. 3x times x is 3x squared. Again, I'm keeping my columns of the constants, the x terms, x squareds. If there was any x cubes or x to the 4th powers or any other powers, I'd have to make new columns for those. So that one is like distributing the 3x to the x minus 2, and you get 3x squared minus 6. Then you just add the two answers together, so you get 3x squared minus 2x minus 8. Again, if you did the horizontal method, it'd be like distributing x to the 3x plus 4 and distributing your minus 2 to the 3x plus 4. So x times 3x gives you 3x squared. Times the 4 would give you 4x. And then this one, be careful, you have to take the negative with the 2. So you get negative 6x minus 8. Then combine these two like terms of 4x and minus 6x. And you get 3x squared minus 2x minus 8. All right, here's a couple for you to try. Go ahead and pause the video. All right, we're back. So I'm going to do the horizontal method. So the first one is 3m times m plus 5. Plus 4 times m plus 5. So if I distribute here, I would get 3m squared plus 15m, and distribute here, I would get plus 4m plus 20. Combine the like terms here, and you'd have 3m squared plus 19m plus 20. All right. Second one, you're going to distribute the 5y to the y plus 8 and the minus 2 to the y plus 8. So distributing here gives you 5y squared plus 40. And here you got to take the sign with it. So negative 2 times the y plus 8 would be negative 2y minus 16. I forgot to put the y on the 40 there. Okay, so from the 5, when you distributed the 5y to the 8, you should got 40y. So that would be 5y squared plus 38y minus 16. And that's your solution there. Okie dokie. All right, a shortcut version of the distributive property for multiplying binomials is called the FOIL method. It's called FOIL because FOIL stands for how you multiply them. F stands for firsts, O is outer, I is inner, L is last. And what that means is if I was multiplying x plus 4 times x plus 2, let me just redo it down here, times x minus 2. I would do the firsts, which I do the first term in each binomial. So x times x is x squared. O is the outer terms. So the outside term here is x, and the outside term here is negative 2, so that'd be negative 2x. I stands for inner, so that'd be 4 times x is 4x. And L stands for the last term. So the last term in this one and the last term in this one would be negative 8. So your answer would be, oops, forgot the squared there, would be x squared plus 2x minus 8. Okie dokie. All right. So let's find the product here. 2y minus 7 times 3y plus 5. Well, if I do the FOIL method, the first give me 2y times 3y, which is 2y times 3y, which will give me 6y squared. Then the outers give me 2y times 5, right there. The inners is negative 7 times 3y, right there. And the last is minus 7 times 5, right there. If I multiply those, I would get 6y squared plus 10y minus 21y minus 35. Combine my two like terms right here to get 6y squared. Oh, that's way wrong. To get 6y squared, I don't know what that was doing there, minus 11y minus 35. Okie doke. All right. So let's do another one here. If I want to do 4a minus 5 times 2a minus 9. So if I do my firsts are going to give me 4a times 2a, which is right here. The outers give me 4a times negative 9, which is right here. The inners give me negative 5 times 2a, which is right there. And the last give me negative 5 minus 9, which is negative 5 times negative 9, which is right there. If I multiply those, I have 8a squared minus 36a minus 10a plus 45. Combine my two like terms here, and I have a squared minus 46a plus 45. Okie dokie, here's a couple for you to try. Go ahead and pause the video. I'll do 2 of them when we come back, but I'll give you the answers to all 4. Go ahead and pause the video. Okay, we're back. So for 2a, if I do the firsts, that would be x squared. The outers give me negative 4x. The inners give me plus 3x. And the last give me negative 12. So that would simplify to x squared minus x minus 12. Okay, 2b, the answer for that one when you FOIL it out would give you 12b squared minus 7b minus 10. 2c is going to give you 2y squared minus 17y plus 30. And 2d, if I FOIL it, 5a times 3a gives me 15a squared. The outers give me negative 20a. The inners give me plus 6a. And the last give me negative 8. So if I combine like terms, the negative 20 and the 6a, 15a squared minus 14a minus 8. And that's our answer for that one. Okie dokie. All right. So notice that when 2 linear expressions are multiplied, the result is a quadratic expression. A quadratic expression is an expression in one variable with degree of 2. When 3 linear expressions are multiplied, the result has degree 3. If you had 4 linear expressions, guess what the degree would be when you multiply them out? Degree 4. If you had 15 linear expressions multiplied together, guess what the degree would be when you multiply it out? Yeah, 15. All right, we're not going to get that crazy, but quadratic expressions are very, very important. We're going to get into them more and more this year and in the following years. So quadratic expressions are important. The FOIL method can be used to find an expression that represents the area of a rectangular object when the lengths of the sides are given as binomials. So for example, in this swimming pool, a contractor is building a deck around a rectangular swimming pool. The deck is X feet from every side of the pool. So like you have the pool, it's 15 by 20, and then they're putting on a deck that is X feet wide around the edges of the entire pool. So it's kind of like the border around a painting, similar thing, or a border around a printed page, something like that. The deck is X feet from every side of the pool. Write an expression for the total area of the pool and deck. So I want the total area. So I have to figure out, well, I know it's 15 feet this way, but the whole deck is how far? I know it's 20 feet across, but the entire object with the deck and the pool is how far across? Well, we need to find an expression for the total area of the pool and deck. Well, I know that area equals length times width, so I have to figure out what's the length of the whole entire pool and deck and the whole width of the whole entire pool and deck. Since the deck is the same distance from every side of the pool, the length and width of the pool are 2x longer. So the length can be represented by 20 plus 2x. Here's why. You're adding x feet on this side for the deck and also this side. So you're adding x 2 times to the 20. I don't know what x is, so I got to add 2x plus 20. Same thing with the width. The width is 15, but I'm adding x feet on this side and this side. So the entire width would be 2x plus 15. This would be 2x plus 20. Alrighty. So the area equals length times width. And notice I have the product of two binomials. I can FOIL that out. The first give me 2x times 2x. The outer is 2x times 15. The inner is 20 times 2x. And the last 20 times 15. I simplify that. And then I can combine my two like terms in the middle and get 4x squared plus 70x plus 300. That is a formula, sort of, that represents the area of the entire pool and deck based on whatever x feet you make the deck. So if I want to make the deck 1 foot wide, this would tell me how many square feet the entire region is. If I want to make the deck 3 feet wide, well, I could put 3 in here, and that would tell me how many square feet the entire pool is. Okay, so the total area of the deck and pool is 4x squared plus 70x plus 300. So what I could do to check this is pick a value and substitute it into my original area expression and my answer and see if it works. For example, if I wanted a pool that was 1 foot, had a deck around it that was 1 foot, okay, I can multiply 2 times 1 plus 20 times 2 times 1 plus 15. So it'd be 22 times 17. And 22 times 17 is 374. Well, if I put 1 into this for x, I'd have 4 times 1 squared plus 70 times 1 plus 300, which is going to be 4 plus 70 plus 300, which gives me 374. So it works out. I should get the same answer because both expressions represent the area of the pool. All right, here's one for you to try. If the pool is 25 feet long and 50 feet wide, what would the area in the pool of the pool and the deck be? Go ahead and pause the video. All right, we're back. So sometimes it helps if you have a pool like this that's 15 or 25 by 20, and then you're putting a deck around it that's x feet on this side, x feet on this side. So the area is going to be 2x plus 20 times 2x plus 25. So if I FOIL that out, you'd have 4x squared plus 50x plus 40x plus 500. So you'd have 4x squared plus 90x plus 500. All right, and that would represent the area of the pool. All right, guys, that's it for this video. Stay tuned for the next one, which will finish up this section. See you there.